Two cars A and B are 340 miles apart and moving directly toward each other. Car A is moving at a speed of 64 miles per hour and car B at 72 miles per hour respectively. If car B starts moving 1 hour later than car A, which equation represents the time t in hours it takes for car A to meet car B? Okay, for the speed problem, always make the table. Here we have car A and this is car B. For the speed problem, we always have a speed, time, and distance. Here car A is moving at a speed of 64 miles per hour. So speed of A is 64, car B at 72 miles per hour, so this is 74. And the question is, which equation represents the time t in hours it takes for car A to meet car B? So the time for car A is t, and time for car B is, it says car B starts moving 1 hour later than car A. So the time for car B is t minus 1, right? Now, what's the distance? We know that the formula for the speed is always distance over time, right? Distance over time. So distance is equal to speed times time. So the distance for car A is speed times time, which is 64 times t, 64t. For car B, distance is speed times time, 74 times t minus 1. Alright, two cars A and B are 340 miles apart and they were moving directly toward each other. So when car A and car B met, they had traveled a total of 340 miles. Let's say this line segment is 340 miles and car A is right here, car B is here, car A is traveling this way, car B is traveling this way, and they meet at some point here. The distance car A traveled is 64t, and the distance car B traveled is 74 times t minus 1. And the distance from A to B was 340 miles. So 64t plus 74t minus 1 is equal to 340. Therefore, the answer is C.